Hello, my fellow scientists, wherever you are. I want us today to look at motion, and we are going to consider a uniform circular motion. So, in beginning by considering a circle, whereby we have a body moving around this circle, and let's say the body moves from point A to B. It will cover a distance S. S is the arc length. It will have covered a distance which is arc length, and say this body has radius r from the center, radius r. Now, the angle swept by that body as it moves from point A to B, it is referred to as angular displacement. R is the radius from the center to that point. Now, the distance covered, arc length, is given by a radius times the angular displacement. Here, S, which is the arc length, is in meters, and R is in meters, also the radius, and the angle theta is in radian. It is in radian. Now, at angular displacement is given by arc length divided by radius. In case the radius is equal to the arc length, that is what is referred to as 1 radian. So 1 radian is defined as the angle subtended at the center of the circle by an arc length which is equal to the radius of the circle. I repeat, 1 radian is defined as the angle subtended at the center of this circle by an arc length which is equal to the radius of the circle. So if you substitute here with 1 divided by 1 is equal to the angular displacement. So that is what is referred to as 1 radian. Now, we look at now angular velocity. Angular velocity is, as the body moves, it has the speed. As it covers, as the body moves in a circular path, it covers a distance. It covers a distance, and that distance per speed per time, that is what is referred to as angular velocity. So angular velocity is defined, it has a symbol omega. Omega is a Greek letter, this one omega. So angular velocity is defined as the rate of change of angular displacement with time. The rate of change of angular displacement with the time. Change, that is change of angular displacement divided by time. In symbols, angular velocity is given by change in angular displacement over change in time. But we know that angular displacement is given by change in distance over radius. So we can substitute change in angular displacement with change in arc length over radius, because the radius does not change. The radius remains the same here. And when we substitute, we are going to get omega can be given by change in change in arc length divided by radius times change in time. But velocity, linear velocity, is given by change in displacement divided by time. So v here is the linear velocity. So as even the body moves in a circular path, it will experience a linear velocity which is tangent to at any given point. So it will have a linear velocity v which is tangent at any given point. It will have a linear velocity v. Now we find that now so from this formula, angular velocity is equal to linear velocity divided by r. We can multiply both sides by r to get v is equal to radius times angular velocity. Now, angular velocity is in radian per second because the angular displacement is given in radian, time is in second. So the unit of angular velocity is radian per second. This one, radian per second. Now, linear velocity is in meters per second. In meters per second. We now want to focus on speed, period, and the frequency. And we know that circumference divided by speed, circumference will be given by 2 pi r over speed. That one will give you time. In the other ones, time is given by distance over speed. So the time we are considering here is period, because the body is moving, it is revolving around the circle. The body is revolving around the circle, and now our time will be period. Our speed will be r times omega. So we find that speed is equal to distance over, time is equal to distance over speed. Time is equal to distance over speed, as written here, circumference over v. So distance here is the circumference divided by the speed. And our circumference is given by 2 pi r. 2 pi r over v. V is the speed. 2 pi r is the circumference that the body covers. V is r over r times omega. Now, r and r can cancel, and we are going to be left with 2 pi over omega. But we know that period is equal to 1 over frequency. So period is the reciprocal of the frequency. So we can substitute here where you have t, the period, you write 1 over f. And from here we can cross multiply. We can cross multiply here. We multiply 1 times omega to get omega, and the frequency times 2 pi to get 2 pi. So omega is equal to 2 pi f. F is the frequency, the number of cycles the body make in 1 second. So distance in radian, this is how we write it, angular displacement over r. Now for a complete revolution, when your body covers 1 circle, it will have covered a distance of 2 pi. 2 pi. Now, in 1 revolution, in radian, the body will cover a distance of 2 pi radian r divided by r, which is equal to 2 pi radian. Now, we know that 1 circle has got 360 degrees. 1 circle has got 360 degrees. So 360 degrees is equal to 2 pi radian. We can divide by 2 on both sides to get that pi radian is equal to 180. Is equal to 180 degrees. 1 radian is equivalent to 180 degrees over pi. Over pi. That is the relationship. Now we want to look at now angular acceleration or centripetal acceleration, which is given by centripetal acceleration, because as the body moves in a circular motion uniformly, the speed does not change, but the direction changes at different parts of the circle. So that body must be accelerating. There is an acceleration which is directed towards the center of the circle, and it is given by v squared over r. But we know that v is equal to r times omega, whereby omega is the angular velocity. So we can substitute where you have v squared, you can substitute it with r multiplied by omega, and you square r squared, omega squared over r. R and r can cancel, and then we get angular acceleration or centripetal acceleration is given by omega squared r. So before we wind up, let us recap what we have seen today, or what we have learned today. Today we have seen that s is the arc length, that is the arc length as the body move around the circle, and it is given by radius times angle, which is subtended at the center. Linear, as the body moves, it has got the angular velocity and the linear velocity. Angular velocity is given by omega, and the linear velocity is v. So this is the relationship. Linear velocity is given by radius times angular velocity. Angular velocity can be given in terms of 2 pi f. Small f is the frequency. And also, we know that from the fact that using the fact that frequency is 1 over period, then we can substitute f here with 1 over t. So omega can be given as 2 pi over t. Now, angular acceleration or centripetal acceleration is given by v squared over r. This can be modified. This can be modified by substituting the value of v here. So the key thing to understand so far from what we have learned in the linear motion, in the circular motion, and we are considering a body which is moving uniformly, is that arc length, the distance, is given by r times theta. Theta is the angular angle. V is given by r times omega, and omega is equal to 2 pi f. And then your omega can also be given by 2 pi over t, using the fact that f is equal to 1 over t. We have also seen that as angle move, we have also seen that as body move around the circle, in one revolution, in terms of radian, it will recover 2 pi in terms of radian, which is equivalent to as 360 or 180 times 2. So you can divide by 2 there. You're dividing by 2 to get pi radian is equal to 180. 1 radian is equivalent to 180 degrees over pi as the body move. So uniform circular motion is very important, and it is very simple if you follow this simple instruction which I have given step by step. Next time we are going to look at the numerical working, or the numerical equation, or the numerical problems which can be solved using this formula. So you are going to see how we can calculate the arc length, the linear velocity, the angular velocity, the period, and the frequency, and also the centripetal acceleration numerically. That is what we are going to concentrate on in our next study. Bye-bye. Thanks so much. May we continue learning this important subject of physics.